Hey VC students, welcome to another video of hok'stutoring. I hope you and your family are doing well in these troubling times. If you're watching this video in the start of 2020, we know that the COVID-19 has hit Australia like a truck. This is a very unexpected event, and I do commend you for actually taking your time to watch this video and really, push yourself hard. And it really pays tribute that you're working hard, you're still studying hard despite all these troubling news. So big props to you, but that's not the point of this video. We are going to be going through a tutorial question today. So that is question 17 on chapter 4a on your maths methods textbook. So without too much further ado, let's jump into the video and let's try to solve this question together. Alright, so let's have a read. Question 17. For which values of k does the equation k minus 3 times by x squared plus 2k times by x plus k plus 2 equals to 0 have, for part A, 2 solutions for x, and then for part B, 1 solution for x. So essentially what this is saying is if you were to solve this quadratic equation, then what values of k would give you 2 solutions, meaning x equals to one number and then x equals to another number, and then for part B, 1 solution, so that means x equals to just one number. That's it, okay? And the quadratic formula to solve for x is given by x equals to negative b plus minus square root of b squared minus 4ac divided by 2a, where a is the first coefficient of, or the coefficient in front of your x squared, and then b is the coefficient in front of your x, and then c is the coefficient in front of your, well, pretty much the one where there's no x at all. So looking at this quadratic formula over here, how can we get 2 solutions? Well, to get 2 solutions, it just means that your plus minus has to stay, right? So that means if your square root over here gives you a number, then you'll get x equals to negative b plus minus some random number. We don't know what it is, but let's call it d for now, divided by 2a. And then the plus would give you one answer, and then the minus would give you another answer. So that's 2 answers. So that's how you get 2 solutions, if basically the square root exists, okay? So square root exist would give you 2 answers, or it gives you a number, okay? Now, how do you get 1 solution? Well, if you want 1 solution, then you basically just need to get rid of the square root. So the plus minus is still there, but if the square root over here, if the number inside equals to 0, then you have a square root over 0, and we know what that gives us, and that just gives us 0. And when you plus minus 0, well, essentially the number doesn't count at all, and you divide it by 2a, which gives you just one answer, okay? So then that would give you 1 solution. So that means that is saying your square root is equals to 0. And then for the last part, it's not here, but just for completeness, if you don't want any solution at all, then what happens over here? Well, it just means that your square root doesn't give you an answer at all, okay? So that means the b squared minus 4ac in the inside is a negative number. So plus minus a negative number in there. And what that gives you is the square root doesn't exist. If the square root doesn't exist, then this overall expression here, equation, does not work at all because you can't square root a negative number. So in that sense, you have no solution. Okay, so that's the frame that we're going to work with. And to summarize, and the book summarizes already, but essentially, if b squared minus 4ac is bigger than 0, meaning your square root exists, there's a number that comes out of it, which is not 0, or it doesn't exist, then that would give you 2 solutions. And if your b squared minus 4ac is equals to 0, then that would give you 1 solution. And then b squared minus 4ac is less than 0, then that would give you no solution, or 0 solution. And the name for the b squared minus 4ac, you can call that the discriminant. So that's a refresher for what you studied a little bit earlier, back in either last year or maybe just earlier this year. So guys, now that we know the theory behind this, we can start working on the equation or working on a solution. So let's do part A. If you want to get two solutions, essentially we just need to find b squared minus 4ac, which in this case, b squared we know is, b is 2k, so b squared would be 2k squared. Put the discriminant in front, and minus 4 multiplied by a, which is k minus 3, multiplied by c, which is k plus 2. And if we were to expand this, we get 4k squared minus 4 times by, well, let's expand, multiply the bracket together. K times k is k squared, k times 2 is plus 2k, minus 3k, because we multiply that in, and then multiply that again, and we get minus 6, and we get 4k squared minus 4 times by k squared minus k minus 6, and then we can try to expand the bracket, and we get 4k squared minus 4k squared. So multiply the negative 4 inside, and then you keep multiplying it. Negative 4 times negative k gets you plus 4k. Same thing over here, you get plus 24. And well, this question makes life a little bit easy because your quadratic has just simplified, and you're left with just 4k plus 24, which is our discriminant. Now, what do we do with this afterwards? Well, what do we want as our solution? We want two solutions, right? So as we can see here, if you want two solutions, you need this to be bigger than 0. So guys, the way I normally do this, and I really highly recommend you do, is you sketch a mini graph of this discriminant, right? And I'll show you why we prefer to do this later on. And I know you can algebraically just solve for k over here, move 24, divide by 4, solve for it. But it gets a bit more interesting when, for example, when your k square over here didn't simplify, or it didn't cancel each other out, and you end up with, for example, k squared plus 4k plus 24 or something, and it says bigger than 0. Then how do you solve for that, right? Like, how do you solve for k or quadratic equation when it's bigger than 0? So this is where the good habit comes in of sketching the graph, because essentially whatever this equation is, can be a cubic, can be a sine graph, can be a cos graph, can be any kind of graph. If you want your discriminant to be bigger than 0, you do your mini sketch and you find out, okay, so if my y, which is now my discriminant, and my x, which is now my k values, you do a mini sketch and you want to find where it's above 0, then you can easily just look at the graph, and then you'll easily be able to determine what your k's value should be. So if I was to take the linear line for an example, it's got a y-intercept of 24, and the x-intercept, well, it's pretty obvious, pretty easy to do, but if you want, you can let this whole thing equals to 0, solve for k, and you get negative 6. And if I was to draw a line, and excuse me, it's not super straight, but that's good enough. It's not marked, it's just a mini sketch for you to help you find the k value so that you get two solutions. In this case, we look at our line, right? And we want to determine when it's bigger than 0. And it's pretty obvious from our graph that k should be bigger than negative 6. And if that's the case, then your discriminant would be bigger than 0. And if we know that our discriminant is bigger than 0, then we get two solutions. So that is part A, guys. So k bigger than negative 6 gives two solutions. And then part B is very easy, guys. Since we've already drawn the graph, we just want one solution. Well, one solution means your b squared minus 4ac, your discriminant, is equals to 0. And in this case, where's your discriminant? See over here, the discriminant axis is equals to 0. Well, that's that point, the x-intercept, right? So if k is equals to negative 6, then that gives you one solution, right? So that's how you do it, guys. So that's a linear line. It's pretty easy, nothing too difficult. And the reason why you want to sketch the graph is especially when you get other equations out of your discriminant. So for example, like this quadratic, and then you might get something that looks like this, for example, and you want to determine for example two solutions. So where would you get that? So you would just need to find where this graph is above the x-axis, which are these two sides, right? So guys, that is it. That's a bit of my tip as well in terms of just sketching the graph to find your discriminants, to find your k-values properly. I hope you found this video useful and insightful to what you studied. And again, I really hope that you are staying safe from the virus. But otherwise, thank you for watching, and if you have any questions, please leave a comment below. Give this video a like, subscribe to the channel for more content, and I'll see you in the next video. Thanks for watching.